Cosmic crashes introducing neutron star mergers. Neutron stars are fascinating objects. They are the remnants of massive stars that have exploded as supernovae. Imagine cramming a star as massive as our Sun into a sphere the size of a city. That's how dense a neutron star is. Now imagine two of these incredibly dense objects spiraling towards each other. This is what we call a neutron star merger, a cosmic crash of epic proportions. These events are not just about destruction. Neutron star mergers are cosmic laboratories. They allow us to study extreme physics and the origins of heavy elements. We can learn so much from these extraordinary events. The study of neutron star mergers is a hot topic in astrophysics. It's a field that is rapidly evolving thanks to new observational tools and theoretical models. We are on the verge of unlocking some of the universe's biggest secrets. The dance begins, the Inspiral. When two neutron stars get locked in a gravitational embrace, they begin a mesmerizing dance. This dance, known as the Inspiral Phase, lasts for millions of years. As the stars orbit each other, their gravitational pull creates ripples in the fabric of spacetime. These ripples, called gravitational waves, carry energy away, causing the stars to inch closer and closer. Imagine two dancers, their movements becoming more and more frenetic as the music intensifies. That's what happens during the Inspiral. The closer the stars get, the stronger the gravitational waves become, and the faster they spin around each other. This cosmic waltz can't last forever. Eventually the stars get so close that their surfaces touch. Then the real show begins. Fireworks in space, the merger. The collision of two neutron stars is one of the most violent events in the universe. Imagine two wrecking balls smashing into each other at nearly the speed of light. That's the kind of energy we are talking about. The merger itself lasts only a few milliseconds, but in that short time, a tremendous amount of energy is released. This energy is released in the form of gravitational waves, light, and other forms of radiation. The merger creates a blinding flash of gamma rays known as a short gamma ray burst. These bursts are so powerful that they can be detected from billions of light years away. The merger also produces a spectacular explosion called a kilonova. Kilonovae are about 1,000 times brighter than a regular nova, and they shine with light created by the radioactive decay of heavy elements. After the storm, kilonovae and more. The aftermath of a neutron star merger is just as fascinating as the collision itself. The kilonova, with its brilliant display of light, slowly fades over days and weeks. We see the fingerprints of newly forged elements in this light. Elements like gold, platinum, and uranium are created in these cosmic furnaces, but that's not all. The merger can also leave behind a black hole, a region of space-time where gravity is so strong that nothing, not even light, can escape. Or it might create a bigger, highly magnetized neutron star. These remnants continue to influence their surroundings, shaping the evolution of galaxies. Studying them gives us clues about the processes that created the heavy elements that make up our planet and even ourselves. Windows to the universe. What we learn. Neutron star mergers are more than just spectacular fireworks. They are invaluable windows to the universe, revealing secrets about fundamental physics and the cosmos's history. By studying these events, we can learn about the nature of gravity, the properties of matter at extreme densities, and the origins of the heavy elements that make up our world. The detection of gravitational waves from a neutron star merger in 2017 by LIGO and Virgo marked a new era in astronomy. For the first time, we could hear these cosmic crashes, adding a new dimension to our understanding of the universe. This discovery confirmed decades-old theories and opened up new avenues for exploring the cosmos. The study of neutron star mergers is still in its infancy, but it holds immense promise. As we continue to observe these events with ever-increasing precision, we can expect to unlock even more secrets about the universe and our place within it.